Okay, guys, I'm going in several different directions, obviously, but here's the key thing. I notice that some of you working, you get stuck on one or two things. I want to give you more options, right? That's why I'm giving you alternate assignments. That's why I'm trying to figure out how you can churn in even notes as well as your work and so on. As you notice, I'm organizing my videos into assignment links, not just regular posts on Google Classroom. But anyways, this is something so basic but important for any of you, right? Whether you're IM2 or IM3 right now. And I hope you embrace this challenge because I'm trying to find important stuff that's easy to learn that you can do and get credit for me. All right? So, this one is about interpreting a quadratic graph. Okay? Again, if you do not find this assignment, I gave it to you earlier today. All you have to do is search this, right? Just type in interpret a quadratic graph. It'll pop up. And the other thing you notice is I now just being more specific, giving you actual practice assignments, a few articles or notes from Khan Academy every once in a while, and very rarely will I sign a video anymore. Okay? I want us to get right to the work, in other words. But anyways, look at this quadratic, guys. This is kind of cool, guys. This quadratic is the growth of mosquitoes when it rains. Okay? So you notice with rainfall in centimeters, although we usually measure in inches, but it's in centimeters, we're figuring out how many millions of mosquitoes will grow and reproduce. Okay? And so notice, guys, the max in this area is going to be right there. We call this the maximum value, correct? And it happens when the rainfall is 2 centimeters and there's 4 million mosquitoes. That's a lot of freaking mosquitoes, right? At 2 centimeters of rainfall. Now, think about this, guys. This is actually why we study quadratics, because there's a lot of things like this that follow a quadratic graph. Okay? Follow the purple here. See, when there's no rainfall, I'm here, and obviously there's no mosquitoes. Mosquitoes like fresh water rainfall because that's how they breed. You see? And the more water, the more mosquitoes. But see, there's going to be a limit, which is right here again. Why? Because once over here, it starts raining too much. See, if I have too much rain and water, it's just going to wash the larvae and the mosquitoes away, you see? And that's why the mosquito population will decrease at a certain point, because if there's too much water, they literally get washed away. Okay, but anyways, let's get to the questions. And you just go through them one by one, guys. A here, the largest possible number of mosquitoes, 2 million. We know that's wrong. We know the maximum is 4 million. The largest possible number of mosquitoes, 4 million. Bingo, we're going to select that. Now, guys, sometimes there's more than one right answer. We got to check them all. More rainfall always relates to less mosquitoes. That's not true. Over here, the more rainfall, we get more mosquitoes. It's after we reach the maximum value, does more rain mean less mosquitoes. See, over here, there's going to be less mosquitoes. So that's why that one is false. More rainfall relates to less mosquitoes as long as the rainfall is less than 2. That is wrong, because less than 2 means I'm over here. And over here, that's where I'm getting more mosquitoes. So, I know it can be a little tricky, the wording, but that's what I want you to practice and get used to. The only correct answer was B. Okay? Let's try a couple more. Again, here we have someone kicking a ball in the air. What's the ball going to do? It's going to go up. It's going to come down. It's a parabola, a quadratic. Now notice the maximum is right here. When this girl kicks the ball up, her name is Sarah, the highest it's going to go, looks like, is around 14 meters high. That's about 42 feet. She kicked it up pretty high, in other words. Okay? And notice, right here is time 0, guys. Remember, time 0 is where things start. And notice, let me erase my marking there. time zero is right there, and it looks like it's at 1 meters. Why? Because if you drop kick a ball, guys, it's still going to be about 2 to 3 feet above the ground when you kick it, right? That's what she did. So the ball didn't start on the ground. It started 1 meter in the air, above the ground, right? It went up. It came back down. Of course, over here, let me clean up there. A little bit around 3.5 seconds, notice. That right there is about 3.5 seconds right there. That's when it finally hit the ground again, right? 0 feet or 0 meters means it hit the ground. Now let's go to the questions. Oh, I didn't do the questions by accident. So guys, let me just tell you what choices you would pick. You would pick choices like Sarah's ball hit the ground at what time? You would say it hit the ground at 3.5 seconds. Get it? What is the highest the ball went? You would say about 14 meters high. At what time did the ball hit? If they ask you that, then you'd want to come down here and you would say about 1.75, 1.8 seconds after she kicks it, it's at its highest point. How high was it when she first kicked the ball? You would say right here at 1 meters. Those are the common questions they're going to ask you guys. They're asking you to interpret what the graph means. All right. Now, hopefully I did a better job on this one. Let me just check. Here we have a company's selling apps, and those are the choices. Okay, good. So on this one, guys, again, notice this is a parabola. Why? Because, guys, if I, for example, sell the app at $0, right here, you see, this is the price. The X here is the price of the app. If I sell something at $0, here's something interesting. Do you think the company is just going to make $0? The answer is no. The company is going to lose money. Why? Because it took money. They had to pay workers to make the app, design the app, and produce the app, right? So you have to understand, in real business, if you don't put a price on something, you're not only gonna not make any money, you're gonna lose money. Okay? So as you can see, they're gonna lose $10 million. Remember, this scale here, if you look, is in millions of dollars. So they better start selling this app, you see? Now, notice as they raise the price, what's gonna happen to their profits? It's gonna go up. But understand, at a certain point, guys, it's gonna reach a maximum value. As you can see, it's about $40 million, $38 million. That's the max profit they're going to make approximately, right? And that's going to happen right here when they sell the app at $7. Okay? But see, what happens if I raise the price too much? Let's say I raise it to $10. Notice my profit went down to only around 30 million. Million, not min. 30 million, right? Why is that? Because when you raise the price up too high, you're not going to sell it as much. So do you understand? There's that perfect price where you can get the max profit for any product that you design, make, produce, or sell. And this is real life math, guys. It follows basically a quadratic or parabola. All right, let's get to the questions. This will be the last one we do. So, the greater the app price always relates to greater profit. As I just explained to you, there's going to be a point where you're going to make it too expensive that people don't want to buy it anymore. Therefore, you don't profit as much. You're going to sell it less. Let's look at choice B. Greater app price relates to greater profit as long as the app price is more. This more than 7 is backwards. We want to be over here where it's less than 7, right? Less than 7, the more we increase it, guys, the higher the profit's going to be. But again, we're going to reach that maximum value where we're going to make the product or app too expensive and less people are going to buy it. So that one is wrong. Let's look at choice C. The largest possible profit they can make is $7. I think that's wrong. They're tricking you. The price is $7. The max profit is 40 million. They're talking about profits. That one's wrong. So as you can see, guys, I'm going to pick D. The largest profit they can make is about $40 million, as we discussed. And I'm pretty sure that's the last problem I did. Now, you're going to have to do one or two more problems similar to this one, guys. And they're going to try to trick you with the wording. They're going to mix up the answer choices on you. Okay? Keep that in mind. But the important thing, guys, is I assigned this to you. It's due 22 May, a week before final grades are due, to give you plenty of time to get this done. And hopefully you realize it's not that hard. And the cool thing is, hopefully you're learning that, hey, these quadratics that we're learning about or have learned about, they actually apply to real life. Profits, mosquito population, the height of something like a ball being kicked in the air, and so on. All right, guys. See you around.